So before we get into our examples, let's look at a few properties of integrals. So if you have a constant within your integral, it's the constant multiplied by the antiderivative plus c. If you have the sum of two functions, you could just find the sum of their antiderivatives plus c. And same thing for difference. You can find the difference of their antiderivatives plus c. So we will be applying these properties below. So we want to evaluate the following. Remember, this means find the antiderivative. So the integral of x cubed would be x to the 3 plus 1 over 3 plus 1. Right? We're working backwards using our power rule. Minus x to the 2 plus 1 over 2 plus 1. Minus 3x to the 1 plus 1 over 1 plus 1 plus c. So this will probably be the only time I show this work of working the power rule backwards. We add 1 instead of subtracting 1, and then divide instead of multiplying. Add and divide. So this is x to the 4th over 4 minus x cubed over 3 minus 3x squared over 2 plus c. So this is our integral of that function, which finds our antiderivative. So once again here, in number 2, we're trying to find the antiderivative, the integral of this function. Well, what's derivative is 4? For x, the integral of x squared is x is x to the 1 plus 1, which is 2, divided by 2. And the antiderivative of secant squared is tangent x plus c. Number 3, for this one I need to simplify it a little more. I'll distribute to get 3x minus x cubed dx. So now I can use my integration power rule. Working backwards, I have 3x squared over 2 minus x to the 4th over 4 plus c. So we add 1 and then divide by that power. Last but not least, here in number 4, I'm finding the antiderivative, the integral of e to the x plus 1 over x plus sine x plus cosine x. So I have a sum of different functions. What are their antiderivatives? The antiderivative of e to the x is e to the x. The antiderivative of 1 over x is ln absolute value x. The antiderivative of sine x would be negative cosine x, because remember, normally cosine x is negative sine, the derivative, but since it's a positive, it's negative. And then the antiderivative of cosine is sine x, and then plus c. So if we know our derivatives by heart and understand how to undo that power rule, antiderivatives are quite easy to begin with.